So 1-6, solving compound and absolute value inequalities. So you're doing two types. There's compound inequalities first. That has nothing to do with absolute value. And then in the last half of the section, you'll be solving absolute value inequality. So what you really need to check for every time is whether there's an absolute value in the problem or not. And then that will tell you what your first step is going to be. So first, we're going to look at these compound inequalities. They are, one type is a conjunction, and the other type is a disjunction, which we'll get to that in a minute. Let's cover conjunction first. These are and inequalities. And your variable is going to be in the middle. Your final answers for a conjunction will look something like this. 2 is less than x is less than 4. Okay, that is a conjunction where your x is in the middle. It's going to look different than the disjunction, which we'll talk about. A disjunction is an or, and it will look like x is less than 2 or x is greater than 4. Okay? So it's going to actually be two separate inequalities. The conjunction is put together as one. So if you were to graph this one, the disjunction, put 0 in the middle, 4 over here. Oops, 0 in the middle. I was thinking it was negative 2. So there are our two values, 2 and 4. Inequality rules still apply to solving these because they are inequalities. So the two rules we talked about last time were open and closed circle. How do we know which is which? How do we know if it's open circle? There's no line underneath, which isn't the case here, right? And then closed circle is when it's got the equal to underneath it. So that still applies here, okay? What was the other thing we talked about with inequality? The other big difference. Anybody know what was different last time? When you were solving them? Flip the sign. If you multiply or divide by a negative, you flip the sign. That still happens here. So when you're solving any of these, if you multiply or divide by a negative, you still have to flip the inequalities. So if we're less than 2, we would have an open circle at 2, and we would shade everything to the left. And open circle at 4, and shade everything to the right that's greater than 4. Normally, not always, but normally, your disjunctions will be going the opposite direction. It doesn't have to be that way. But if you see one that looks like this, that's normally the case, that it is a disjunction. The conjunction is shaded in the middle. That's how you know it, and that's how your graphs will look. So this one is between 2 and 4. That's what this basically means, is x is in between 2 and 4. You still have open circles, and you shade in the middle. Okay, that's what a conjunction graph should look like. So make sure you know all of those things about both of those. And now we'll go ahead and do some examples of each one, how to solve. That's what they should end up looking like. Your final answer should be that and that, or that and that, depending. So if you have 13 is less than 2x plus 7, which is less than or equal to 17. You need here just so less than or equal to 17. So we have a conjunction or disjunction here. Check back, look up there. What? Conjunction. Okay, the x is in the middle. So what our goal is to keep the x in the middle and get rid of the 2 and the 7. Which one do you think you'd get rid of first? The 7. So how would we get rid of the plus 7? Subtract. The only difference here is you have to subtract from all 3 sides. Since there's 3 sides there, you got to subtract 7 from everywhere. So that leaves us with what on the left? 6 is less than 2x, which is less than or equal to 10. Is our x by itself in the middle. So what do we need to do? Divide by 2. And again, you do that on all 3 sides. So we would have 3 is less than x is less than or equal to 5. So does that look like what it's supposed to look like from your example up here? Yeah, you got x in the middle. And now we got a graph in the middle. So draw your number line. And again, I'm not real particular about that. Just show me the numbers and show me where 0 would be. So do we have an open or closed at 3? Open. Open. Because there's no line under there. Do we have an open or closed at 5? Closed. Closed. And we shade in the middle. Okay? That's a conjunction. Anytime they look like that, that's what you're going to do. Just get the variable by itself in the middle. Anybody have a question on those, on the conjunction? Let's look at a disjunction problem. Y plus 5 is less than or equal to 7. This is how a disjunction will look. Or y plus 4 is should be y minus 6 is greater than 2. So now you just have 2 separate inequalities and you solve them both. So over here, what would we do to solve for y? Subtract the 5. So we have y is less than or equal to what? 2. Or over here, what would we do? Add the 6. And we have y is greater than 8. Again, that looks just like the disjunction example from up above. So we draw our number line again. Zero, 2, and 8. Are we closed at 2 or open? Closed. And we shade less than, arrows pointing to the left. For greater than 8, it's open. And we shade to the right, everything greater than 8. Questions on the disjunction. So my question now is, did any of those problems have an absolute value? No. So if it doesn't have an absolute value, you just solve it. No problem, right? Now, I will get into the absolute value. We've already done absolute value equations back in one of the other sections where we had absolute value maybe 2x plus 3 equals 4. That's an absolute value equation. It doesn't have an inequality in it. How did we solve that? Does anybody remember? Hopefully a lot of you do, what do we have to do?
To rewrite it.
Yeah, we had to split it into two, right? Getting rid of the absolute value, we just write 2x plus 3 equals 4. Or 2x plus 3 equals negative 4. Have to know that rule. That's what I'm talking about on the test. Some people will just solve that. They'll subtract 3 and they'll divide by 2 and they'll move on. And that answer will probably be on the test. Okay? You've got to know. If that's an absolute value equation, you have to split it up. You also have to know that you no longer have absolute value in there. That's how you get rid of the absolute value, is by splitting it up. And then we would solve them both, which I'm going to hurry through this. Probably make a mistake. And you got your two answers. Okay, that's how you do the equations. And then today, we're going to do the inequalities with absolute value. Here's your two rules. Because you're going to have to split the inequalities up as well. Here was your absolute value equation. This is how you split that up. To split up the inequalities, you're going to either do a conjunction or a disjunction. And I'll tell you right now how you know which one you're going to do. And again, you'll have to just know this rule. If you have absolute value greater than, it is a disjunction. If you have an absolute value and then greater than something, it is a disjunction. What I mean by that is if you have 2x plus 3 greater than 7, I'll put a 7 to look like greater than. So we have absolute value greater than. That's how you know. And you always want the absolute value on the left. So if it's not on the left in your problem, you want to rewrite it that way. You always want the absolute value by itself on the left side, and then this sign tells you whether it's a conjunction or disjunction. Question?
What if it's greater than?
Same way. Good question. It can be greater than or equal to. That doesn't have any effect on whether it's a conjunction or disjunction. All that really affects is whether it's closed or open. Okay? Absolute value followed by a greater than. And if you don't, some of you don't know what greater than means. If the alligator's mouth is eating the absolute value, it is a disjunction. However you have to remember it, you have to remember that.